Hello, physics students. We are going to deal with that problem, doing it the other way. So we're still going to have our Vxi that we figured out was the 49 meters per second. That was where we used the Vi cosine of the angle to get that. And we still have our Vy x, so our initial velocity in the y direction, as 13 meters per second, which again came from the Vi sine of theta. Okay? But if you don't have a graphing calculator to use at home, it is possible to get to the answer without using a quadratic solver. So we still do need to get our change in time. To get there, I'm first going to start with, this equation, that Vyf squared equals Vi sine of theta squared plus 2ay delta y. And again, I want to get just my final velocity, not its squared. So I'm going to do the square root of all of this. So starting with that equation and plugging in my numbers, so Vi sine of theta was 13 meters per second, and I have to square that, plus 2 times negative 9.81 meters per second squared. Sorry, I'm going to run out of room. Times my delta y, which was a negative 15 meters. Okay. When you do that, you should get your final velocity as negative 22 meters per second. And it's negative because I had the plus and the minus here. And I chose negative because I'm falling down. So it's negative because we're falling downward. Okay, that's why. So now that I have my final velocity, I can use this equation. Okay. So we have Vi sine of theta plus ay delta t. Okay. I have to solve for delta t. So again, most of you prefer to kind of plug first, right? So Vyf that I just figured out was negative 22 meters per second equals Vi sine of theta was 13 meters per second plus a negative 9.81 meters per second squared times delta t. So when you solve that, doing your manipulations and such, you should get your delta t to be 3.6 seconds. Now I have everything I need to figure out my delta x. To use this equation. So again, Vi cosine of theta was the 49 meters per second. times the 3.6 seconds, okay, gives me 170 meters. So the point is that it is possible to solve this problem without using a quadratic equation. So if you are more comfortable doing it without a quadratic equation, this is how you would do it. Again, these just came from what Mr. Crosby did in class. Okay, this is that equation. Okay. Again, we did the square root here because this was squared, okay, and so we had to take the square root of it. When you do that, okay, you end up with this negative 22 meters per second as our final velocity in the y direction. I can use that then to find my delta t by manipulating this equation using my negative 22 meters per second, and again, those numbers that I know, to get my time of 3.6 seconds. Once I have that, then I can figure out my delta x, which is 170 meters, which means that when we're talking about that picture, okay, that this was a negative 15 meters, that means that this here is 170 meters. That's our delta x. So I hope that that helps. Thanks.